Welcome back. This is part 2 of our discussion on the homework for section 7.1 on Cartesian vectors. So let's carry off from where we left off. We're on question 5 now. So 5. So this question, we're given the vector v, 5, -1, and we're asked to state its vertical and horizontal components. This is quite relatively easy. V of x, v of y. Well, v of x would just be 5. And then v of y is just -1. Perfect. Part B. Find two unit vectors that are collinear with v. So remember, what it means to be collinear is if we have some vector v, we either scale it down to be of unit length. So it would look something like this. This process actually has a name. It's called normalization. So that's a fancy way to just say we're taking our vector and we're making it of unit length of 1. That's not probably the scale, but you get the idea. Alrighty, so let's begin. We first got to find our vector's magnitude, so let's do that. Magnitude of v is equal to, using the Pythagorean theorem, 5 squared plus -1 squared. We get square root of 26. Okay. So then one of the vectors, I guess we'll label it u1, would be, this is the formula for the magnitude of a unit vector. So then this is just 5 -1 square root of 26. Okay. Now a second one, that's kind of seems kind of strange that there would be a second one, but there is, and it's just in the opposite direction. So then u2 would just be negative. So we get, I guess we could distribute this in. You'll learn this sooner or later, but so I distributed this negative inside the vector v here for this second equality. All right. Question part C. An equivalent vector PQ has its initial point P at -2, -7. Determine the coordinates of Q. So the vector PQ looks something like this. Its initial point P is -2, -7. So we don't know. We're trying to find the components of Q, so we don't know what QX is. So we can do that. And then minus -2 is the same thing as +2, right? So QX plus 2. And we need to find the components of QY. And that's minus -7, but that's the same as +7. All right. But the problem, we know that vector PQ is equivalent to vector V. So then QX plus 2, QY plus 7 equals our vector 5, -1. So then we get two equations we can solve. QX plus 2 equals 5, and qy plus 7 equals -1. Then this implies that qx, qy, well, qx would be then 3, and then qy would be -1 minus 7 minus 8. All right. Is that all the questions asking? Yep. So we have our vector q is just then 3, -8. Alrighty. Moving on to part D. An equivalent vector Lm has its terminal point at M58. So this is the same deal as the previous question. It's just almost in reverse now. So the point, we have the terminal point at this point. And terminal point at this point, that sounds funny. So it's going to be 5 minus Lx, because we're trying to find our components of L. And we have 8 minus Ly. And business is as usual at this point. So then we have Lm, again, is equivalent to V. We're going to get two equations out again. 5 minus Lx, 8 minus Ly equals 5, -1. Equate the x and y components. So then we have 5 minus Lx, 8 minus Ly. This equals 5. And then this equals -1. So that implies Lx equals 0. And Ly equals -1 minus 8 should equal 9. So then our vector L is 0, 9. Nice. Perfect. Or I guess it's not a vector in the sense, it's a point. Yeah, so we found the how to define the point Q in the Cartesian plane and how to define the point L in the Cartesian plane. Alrighty, moving on to question 6. I might give myself some room to draw here. This might not be to scale, I apologize. So we have -6, 1. Somewhere around here, maybe. We have the point -2, -1. Oh, sorry. -6, 1 is above the x-axis, not below. -2, -1, that's the point Q. That can be maybe somewhere here. And then the point R, -3, 4. So that would be somewhere here-ish, maybe, and here, I guess. Okay. Connect this up. All right, and let's get to finding our vectors now. So, A, we have QP. Realistically speaking, I wouldn't even actually need to draw this. You can just work with this algebraically and complete all A, B, and C like that. The drawing is extra, but it helps to visualize. It's always good to visualize in math. QP equals, we're going to have QP. So we have -6 minus -2. And then 1 minus -1. And that's equal to -6 minus -2 is -4. 1 minus -1, that's 2. Okay. B, RP. That's going to be, oh, so it's the magnitude of RP. So let's first calculate what RP even is inside the braces. So we're going to have -6 minus -3. And 4 minus 1. Yeah. Actually, no, I screwed that up. It's going to be RP -6 minus -3. P, and then 1 minus 4. That makes sense. Okay, and then we have -6 minus -3, which is -3, and then 1 minus 4, which is -3. So this will be -3 squared twice, which is the square root of 18. Alrighty, that's good. And then it's asking us to calculate the perimeter of triangle PQR. So, perimeter. We're going to need all the side lengths of the triangle. So, we can definitely use, we'll use RP because we got that one. That one would be definitely useful. We might as well use QP as well. So QP, because we're almost done that. We can just calculate it at the end real quick. So we have RP, QP, and why don't we do RQ as well? Okay. So RP we know is square root of 18. QP, the modulus of that is going to be -4 squared, 2 squared, square root of 20. That's just, if you really want to know, it's just -4 squared plus 2 squared. Okay, and this final guy. Oh. So what is this one going to be? RQ. That would be, let's see here. So we're going to have to find the vector RQ, the modulus of RQ. I'm going to do this quite quick. So RQ, -2 minus -3. And then -1 minus 4. Yeah. 10. So then we get -2 minus -3. Oh. One. And then you get -1 minus 4. So you get 1, -5. And that's modulus of square root of 26. And then at this point, you don't have to have an exact value. So square root 18 plus square root 20 plus square root 26. That's 13.8. 1, I guess. Good. Moving on to question 7. If u is equal to 4, -1, and v is equal to 2, 7, find 8u minus 8u. So there's quite a few here. I'm probably going to only do a few. So u is 4, -1. And v is 2, 7. Let's do b. b is -8u, which is just -8, 4, -1. And then this becomes, you can just multiply it in, -8 times 4, -32, and -8 times -1, which is just 8. So essentially, scalar multiplication multiplies each individual component of the vector. Good. Let's do E. Yeah, let's do E as well. And then I think I'll call it a wrap, and then I'll let you guys do the rest. 5u minus 3v. Okay. So 5 times u for -1 minus 3 times v, which is 2, 7. This becomes 20, -5 minus, distribute that 3 in, becomes 6, 21. 20 minus 6, that's 14. And we get 14, -5 minus 21. -26. Yeah. All right. And question 8. Let's conclude off with that. Which vector is not collinear with A equals 6, -4? So A -4. So let's first recall, I guess, what it means to be collinear. Collinear just means parallel. So it would be something like, if this is our vector A, this is not the exact vector A, it's some arbitrary vector. And a collinear vector would be lying essentially along this line. It could also be in a different position. It doesn't really matter. And you would see other lines, I guess, like that. All right, so that's what it means to be collinear. Pick a factorially. But what does it mean in the vector sense? How would we write it down mathematically? Well, it just means that to be collinear means that you're a scalar multiple of A. So, let's see here. To be collinear, I think there's two L's. To be collinear means that there exists some lambda, which is any real number, such that this S dot T is shorthand for such that A is parallel to lambda A. Okay, so let's see if any of these are not scalar multiples. So 6, -4. Well, so B in this case, divided by 2. So this is equal to 1/2 A. Use a thinner one. Nope, it's not good. So this one is collinear, so it's definitely not A. What about the other ones? I think it's parallel to 1/2 A. This one seems parallel to negative A. Yeah. What about this one? This one also seems to be some sort of a match. Yeah, so this one's parallel to -3/2 A. So that leaves this one as the only remaining one. And it makes sense because there is no scalar you could use to multiply A by to get C at all. So that's the vector that's not collinear. Okay, I think that is good enough. We've probably gone for a bit longer than I expected. We'll conclude with the next section.